Hello everyone, we're standing here today at the World Hydrogen Summit in Rotterdam, organized by the Sustainable Energy Council. My name is Johan Wiebe from Hydrogen Standard, and with me here today stand two gentlemen. Peter Schafer, Team Leader Senior Engineering from Angst+Pfister, and Marc Stahlhofen, Managing Director from also Angst+Pfister. Welcome, gents.
Yeah, hey, welcome. Nice to be here.
Good morning, Johan. Nice to be here.
Fantastic, thanks. So we'll start off with Marc first, and then afterwards we'll have a couple of questions for Peter. So Marc, tell us a little bit about Angst+Pfister. What do you guys do?
Well, Angst+Pfister in a nutshell is a over 100 years family-owned company that, so to say, generates innovation in elastomeric materials across the value chain. This is our key and our profession. It's situated in Switzerland, in Zurich, but nowadays distribution all around the world. That means subsidiaries in Europe, in China, expansion to the US, especially in process market, and so we're here. That's why we're here for the H2 initiative.
So thank you, Marc. What is your role in the business?
I'm from sales. Actually, my profession is engineering, so I think everybody in our company has a profession for engineering. That's the question. The most important thing as an MD is getting the company into this prosperous market.
Getting a company in a prosperous market, a bunch of engineering you put together, and magical things will happen. And those magical things Peter will tell us now about. But before you do, Peter, quick introduction from you as well, please.
Yeah, I'm responsible for the development of new sealing solutions. So we are a global acting company, but we have a central development department which is mainly located in Switzerland, and we support all our subsidiaries in the world with our developments for sealing.
Great, so sealing is the topic of conversation today, and the products that you guys are actively producing. Tell us a little bit about that, and particularly the sealings products that are used in the hydrogen industry.
Yeah. For the sealing business, we are active in the hydrogen market, and here we are supplying and developing seals for a broad range of temperature range, beginning from the cryogenic temperatures up to 250 degrees, and also pressure-wise we are covering applications up to 1000 bars.
So if I understand it correctly, it's gaseous as well as liquid hydrogen that you guys occupy with?
Right, yes. If it comes to the cryogenic applications, we mainly are focused on PTFE and thermoplastic materials. And if it comes to the high pressure applications in the gaseous hydrogen situation, we have elastomeric materials already validated and in the market applied and verified for a for a broad range of products.
Great, so those products, what are those products?
Yeah, well, it's, for example, valve applications, high pressure valves, static sealings for high pressure valves, but also dynamic sealings in high pressure valves. When sometimes PTFE is a material of choice because of the lubrication behavior of the material. But when also in combination with fuel cells and electrolysers, we are supplying static and dynamic sealing applications.
So if I understand it correctly, your sealing applications are used in the upstream as well as the downstream market of the hydrogen industry.
Yes, it's when based on the components mainly, and when it doesn't matter if it comes to the up or downstream.
Okay, excellent. Tell us a little bit about sort of the raw materials that these sealants are made of.
Yeah. So if it comes to the choice of material, we have focus on elastomeric materials. If it comes to with high pressure applications on EPDM, HNBR, FKM, as well NBR, and we have validated these materials already in an extended test programs, testing for permeation, leakage and rapid gas decompression. We are ongoing with a long time aging test in pure hydrogen. All tests has been done in pure hydrogen. So we have already a material portfolio available in 90 Scha A hardness and 70 Scha A hardness classes for wet elastomeric materials. And if it comes to the dynamic applications, we are focused on, as I mentioned, thermoplastic materials like PTFE and PEEK compounds.
That's a whole list of different materials that are being sort of like combined or sort of like put into a product to serve its purpose. You guys didn't come by that sort of solution overnight. There's a advanced process that goes behind it that sort of comes up to eventually the composition of these products. Validating and testing is one of them. Could you tell us a little bit about that?
We make this extended test program in laboratories on the one hand side, and then also on customer projects we are testing this material in the application itself. It comes to pressurized valves, we are going for long-term tests with high pressure testings, and these materials are already on a very good validation state, and we can offer that to the market as a verified material for application.
Great, Peter, for that explanation, extensive explanation of the various materials and the composition of the raw materials they're made of and what applications they're used in. Marc, then over to you finally. What does the future hold for you guys? Where are those products going to be used and what applications? What do you think?
Well, at least I think H2 is the major energy source for the future. That is why we need to be as Angst+Pfister ahead. That comes to testing, that comes to development, but also be ahead in the market, see what applications are running. Where can we support our customers, our clients to get in? And that is, we are in deep discussions and also in co-working with a lot of institutes, exemplary for the Fraunhofer Institute. They are leading in innovation regarding H2. Yeah. This is, I think, for us, the future.
Great, thank you very much, Peter Schafer and Marc Stahlhofen from Angst+Pfister.